All right, welcome to Unit 1, Lesson 15. This is Part 3. My goodness, this has been a long lesson, but we're almost done. We have these 4 problems, and we're out of here. So let's do them and get this over with. Dividing complex numbers. All right, so when we simplify a fraction, I'm about to write in red. I just want you to listen. You don't have to write this down. If I have 7 over radical 3. If I want to simplify that, okay, I can't have a radical in the bottom of a fraction, okay? I cannot, and let me repeat this, if they ask for it in simplest form, I cannot have a radical in the bottom. So I multiply by the radical, and I get 7 radical 3 over 3. Now keep in mind what I did here. Whatever I multiply to my denominator, or the bottom of the fraction, I have to multiply by the top in order to keep it the same value. Let me give you an easier fraction. If I have 1/2, and if I just multiply the bottom by 4, that's 1/8. That is not the same as a half. But if what I did to the bottom, I also do to the top, now it is 1/2. So what I do to the bottom, I have to do to the top. That's the first golden rule here. And the second golden rule is, if I have a radical in the bottom, it is not simplified, okay? I have to get it in a state to where there is no radical in the bottom, all right? So let me get rid of this and bring us back to complex numbers. So how do I get rid of a complex number? Number 1. And number 2, more importantly, why do I need to get rid of it in the bottom? Let's remember, that's radical -1. So technically, I is a radical. I cannot have it in the bottom of a fraction. So I'm going to go back to where we ended part 2 of this video for lesson 15. Okay, it's on the previous page in the notes. And you'll notice we multiplied these 4 problems. Okay, you'll see all these here. We multiplied these 4 problems by its conjugate. Okay, that's the huge word here. When we multiplied by the conjugate, 3 minus 4i, the conjugate was 3 plus 4i. -3 minus 8i, the conjugate is -3 plus 8i. And you'll notice all of our answers were not complex anymore. The i's went away when we multiplied by the conjugate. Okay, and that's going to be useful when we get rid of the fraction here. When we get rid of, the I in the denominator of this fraction. So I'm going to multiply I by its conjugate, which is -I. What I do to the bottom, I need to do to the top. So let's multiply this out. -I times 19 is just -19i. And that's fine if there's an I in the top. We can have a radical in the top. We just can't have it in the bottom or the denominator. So let's multiply our denominators here. Okay, positive I times -I is -I squared. Okay, and another golden rule to never forget, I squared is -1. So instead of -I squared, I have -1 because I squared is -1. What happens when I negate a negative? It turns to a +1. So I got -19i over 1, which we can just say is -19i. No more imaginary number in the denominator. Now, for every one of these that we do, the denominator will not always go away, but the denominator should always end up without an I, or it should not be a complex number. Now, let's not forget, our calculator can multiply, add, do whatever to imaginary numbers. And I just want to show that to you one more time. Turn on. There it is. Okay, so if I look at my denominator here one more time, if I multiply those together, ultimately, I should get 1, shouldn't I? So the first thing I want to do is go to mode, and I want to make sure that I am in complex setting. Okay, it's A plus BI. All right. Now, I quit that. And above the point, okay, above the points here, the decimal point in blue is I. So I'm going to take I and multiply it times negative I. And if I hit enter, I get 1. That is so cool. I love that the calculator does that. That's exactly what we did here. Okay, we took I times negative I, and we ended up with 1. Perfect. We could do that knowing our rules, but it's always nice of the calculator to check. The calculator should not be the way you do things unless you're coming up with a regression and stuff like that. But for basic math, the calculator should be used for checking, okay? Because you want to be good. You want to be sharp, all right? Let's take a look at number 6. And for the sake of room, you know what? I can move these. I squared is negative 1. I'll put that here. And then, oh, boy, right there. This, okay, right here. Here are 2 little things to remember. And let's just get rid of that. All right, so the second one, or number 6. I'm going to multiply the denominator, 4i, by its conjugate, negative 4i. What I do to the bottom, I have to do to the top. Let's take care of the bottom first. Positive 4 times negative 4 is negative 16. I times I is I squared. I know I squared is negative 1, so negative 16 times negative 1 will result in a positive 16 in my denominator. Boom. Okay? Now be careful with the top, because you have a binomial, or you have 2 terms here, which means you have to distribute my negative 4i to both terms. So let's start out by multiplying negative 4i times 9. That's negative 36i. Okay? And a negative 4i times a positive 3i. Well, a negative 4 times a positive 3 is negative 12. I times I is I squared. We know I squared is negative 1, which means negative 12 times negative 1 is positive 12. And I still have negative 36i. Boom. So let me rewrite this nice and neat. All right? I have a fraction here. On the top, I'm going to write this in A plus BI form, meaning I'm going to write my number without the I first. I have a positive 12 minus 36i all over 16. Now, I can actually reduce this. There is a number that goes into all 3 of those terms. Common factor between 12, 16, and 36 is 4. So I'm going to reduce those all by dividing them all by 4. 4 goes into 12 3 times. 4 goes into 36 9 times. And 4 goes into 16 4 times. So when everything's all said and done, it's 3 minus 9i all over 4. If this were multiple choice in a test, simplest form would look like that. This, what I had in green, although it's correct, it's not in simplest form because it could be reduced. All right, we're doing so good. Let's get rid of this. Bam! Bam-o! Shablam! Number 7. Okay, now we're on to number 7. 4 plus 5i all over negative 3i. All right, our denominator, negative 3i. The conjugate to negative 3i is positive 3i. So I'm going to multiply the bottom times 3i. And what I do to the bottom, I have to do to the top. So let's get started, shall we? Let's multiply these denominators together. Negative 3 times positive 3 is negative 9. I times I squared, or excuse me, I times I is I squared. And we know I squared is negative 1. So negative 9 times negative 1 gives me a positive 9 on the bottom. Simple. Now let's not forget we need to distribute our top. Okay? So 3i times 4, well, that's just 12i. 3i times 5i, well, 5 times 3 is 15, plus 15. I times I is I squared. I squared, we know she's a negative 1, and 15 times negative 1 is negative 15, and I still have my 12i up here. So I get 12i minus 15, and all I'm going to do is rewrite this, okay, in a plus bi form. So my number without the I, which is negative 15, gets written first. My number with the I gets written next to positive 12i. And then I have my denominator, which is 9. And if I am not mistaken, that can be reduced. There is a number that goes into all three of those bigger numbers. 15, 12, and 9 all have a common factor of 3. 3 goes into 15 5 times. 3 goes into 12 4 times. 3 goes into 9 3 times. So when I rewrite that in simplest form, negative 5 plus 4i all over 3. Mamma mia, that's a good as sauce. All right? And it's weird what we started with what we ended up with. Don't try and make sense of it. Sometimes it happens where it's funny like that, and sometimes it doesn't. All right? Look at the way 19 is. Or excuse me, look at the way 5 is. Look at the way 6 is. And look at the way 7 is. But there's one thing that 5, 6, and 7 have that 8 does not. 8, the denominator, it's a binomial. There's a 4 and a minus I after. The top, or excuse me, the 5, 6, and 7 only have one term in the bottom. Okay? So let's take a look at number 8, shall we? Now, number 8, let me erase this right here, and we're almost done. This is the last problem we're doing. The conjugate to 4 minus I is 4 plus I. Okay, what I do to the bottom, I have to do to the top. All right? So how do I know I need to use the conjugates? To get rid of my denominator? Because there's an I, a complex number, which is radical negative 1 in the denominator. All right? So, oh boy, foiling. We got to foil the top and the bottom. 4 times 4 is 16. I'll write this out here. 4 times a positive I is positive 4i. All right, negative I times 4, it's negative 4i. And negative I times positive I is negative I squared. Let's clean this up. Okay, the 4i's cancel, positive and negative. I squared is negative 1. So I'm negating a negative 1. So I end up with 16 plus 1, which is 17 in my denominator. All right? It's fine. It's fine. It's good. It's good. It's good. Now, okay, let's do the foiling on the top. Now, please, if you look at the bottom, those are conjugates. The I will go away. My denominator multiplication. Foiling. If I look at the top, those are not conjugates. The I will not go away for the numerator. And that's fine, because you can have an I in the numerator. Every answer that we have for 5, 6, and 7 has an I in the numerator. Okay? Oh, I erased that other one. But you'll see it's the bottom that can't have the I in it. Okay? So let's FOIL, shall we? Negative 4 times positive 4, that's negative 16. Okay. Negative 4 times I, minus 4i. All right, let's go different color for the sake of ease. Negative 7i times 4 is negative 28i. And negative 7i times I is negative 7I squared. Okay, well, we know I squared is negative 1. A negative 7 times a negative 1 gives me a positive 7. And now I'm going to combine like terms, okay? I have negative 16 and positive 7. Okay, negative 16 and positive 7 give me, oh, wait for it, negative 9. Bam. All right. And now I have minus 4I, minus 28I, and that gives me minus 32I all over 17. There is not a common factor there. And for poops and giggles, because sometimes I do something and I did an answer key for it days ago, and I'm trying to remember if the answer looked somewhat similar to that. And every once in a while, I'm like, did I make a mistake on the answer key or on the board here? Like last video, part 2, I made a mistake, and I put it in the notes for that video, okay? Something like the square root of 25, I put as 2 instead of 5, because the way my mind thinks is it's 5 squared is 25, and I wrote a 2 for the squared instead of a 5. But I made that comment on the note. You know, I'm not superhuman. I make mistakes. But I want to check this one right here, just for poops and ha-has. All right, so let's turn this back on. We should still be in A plus BI mode, and we are, if I look right there. It's A plus BI mode. All right, and I'm literally going to multiply the tops and bottoms together in this calculator and see what it gives me. Because I'm in A plus BI mode, my answer will be in A plus BI. It will be complex. So I'm going to take the numerator, which was negative 4 minus 7I, all right? And I'm going to multiply that times 4 plus I. Okay, and I should get negative 9 minus 32I, and there it is. Oh, beautiful. All you guys want to throw something at your computer screen because the time we took to do it versus what the calculator can do for us. Okay, now let me check the denominator. That should be 4 minus I times 4 plus, and let me make sure I didn't make a boo-boo here. And I should get 17, right? And I did. And look, there's my fraction right there. Look at all that work the calculator did without showing any work because it's a calculator. Our fraction is right here. Look at that. You are very, 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 very welcome for that, buddy. All right. Hey, you're doing good. Don't think I don't notice the work you're putting in. Keep up putting in that hard work. It's going to pay off in the end. All right. We'll see you later. I think this is the last lesson for Unit 1. We have a unit test coming up in my class. So the next videos I put up will be for Unit 2. Thank God it's been a long time that we've been in Unit 1. See you later. Have a great day.